Okay, so we're just going to continue where we left off. Have your calculators ready to go. If you can. 1 second here. Okay. All right, so we did conversions. It's just you're going from one unit to another unit. That's basically what yesterday was all about. Next, let's continue here. It gets a little trickier. For example, when you get to page 3, okay? When you get to page 3, here you have to pay close attention, okay? Pay close attention to this one. Page 3E. So you're going from squared inches to square feet, okay? So what's about the square, that's what I want you to watch out for. This is not just going from inches to feet, this is going from squared inches to square feet, okay? So I start the same way. You can do one of two things. Just understand how conversion works by using the basic conversion ratios I gave you, or you go to your study sheet and look up, see if you have the one that gets you from square feet to square inches. What am I talking about? Let's go back to page 2 here. You actually have that. 1 square foot has 144 squared inches. You see that? And so we can just use that one to simplify things. So we know that 1 square foot has 144 squared inches. And if you think about it, where did we get this? Well, if you know that 1 foot has 12 inches, if you square both of them, you have 1 square foot, 144 squared inches. Okay, so that's important here. So we cancel those out. And really, it's this times that divided by 144. That's what it is. So I'll just 47.2 divided by 144 essentially. So that's 3.8 square feet. That's it. It would be wrong to just use 1 foot as 12 inches. It would be completely wrong. Okay. So you have to make sure you match your units there. So that's areas. Next, we've got cubic meters to cubic yards. I will do this a little differently because I like you to see how everything is connected. Okay. So 9.87 cubic meters. I'm going to use this fact right here. Can you see that? I hope so. I'm going to use this. I'm going to pretend like I don't have my study sheet on me. But I know this. I know that yards and meters are related in this way. So this is what I'm going to do. I'm going to go 0.9144 meters down here. And up here I'm going to go 1 yard. And that is a problem, right? Meters, cubic meters, they cannot cancel. Okay? So what you do is you take this whole ratio and you take it to the power of 3. And now you're having nightmares from intro to applied and pre-cal, right? Remember simplifying those expressions? That's okay. It's not going to be that bad here. Okay? So I'm going to treat it this way. I'm going to go 9.87 cubic meters. The top part of the fraction is very easy. It's just 1 cubic yard, because if you raise everything to the power of 3, that's what you get. The denominator, let's do that together with our calculators here. I'm going to go 0.9144. You remember to the power button, to exponent, is that hat, to the power of. And I have to stop here for a bit. You might have your calculator might be in a slightly different setting where it doesn't do what mine does. As soon as I press the hat, it kind of goes up. Yours might just insert that hat. So I can figure that out with you later on. It's an easy fix. It's just a setting that I need to change. But anyways, I'm going to raise it to the power of 3. You can put brackets around it if you want, but because there's no negative, we don't need to worry about brackets. Okay? So we're going to raise it, and watch what I'm going to do here. 0.764. I want to use all of them. Dot, dot, dot. Cubic meters. I hope this makes sense what I just did. I took the basic ratio, I raised it to the power of 3, so now everything is cubed. Now I can cancel this. Now you can go ahead and do this. So satisfying. It's gone, right? And now use your calculator. That's why your calculators are very powerful, and you don't have excuses not to use all your decimals. Watch this. I'm gonna go 9.87 divided by this number. You can copy paste. Watch this. So you go divided by, then you go arrow up, highlight the number you want, press enter. It's going to copy it in there. Isn't that cool? I find it cool. Then you hit enter, and so this is the answer you get. It's 12.91 cubic yards. That's your final answer. And I'm gonna highlight that fact, right? That it went from cubic to cubic. So because of the cubic meters there, I needed to make sure I canceled that out, right? So that's very important to understand. That's volume. Mr. Jackson, this is going to be very popular because I'm scared of this. It's not going to be that popular. Most of you are probably going to go to your study sheet and just go get that number. Like you're going to have, I don't know if I gave you this on the study sheet, probably not. This is not on there. But most of them, you're just going to go get it from your study sheet and just convert it. Because I gave you the main ones already. I asked you to fill out your study sheet with it. Okay? So this is coming back. You're going to get to practice this. And that's the only way to learn math is by practicing. All right. Converting rates. So this is where things change a little bit. What's the difference between rates and ratios? It's the fact that rates have different units. So kilometers per hour, here's kilometers and hours, right? So that's how it's different. But we approach it the same way. We solve them the exact same way. So 42 gallons per minute, you want it in liters per hour. Okay, so start the same way, watch this. 42 gallons, and you put 1 minute like this. Earlier we didn't have that extra number underneath, but now we do. So you need to make a choice how you want to start. First off, we want to make sure gallons is turned to liters and my minutes are turned to hours. That's what we want to do. I want to start with the gallons to liters. So this is what I do. I know that 1 gallon, I want to put it down here because I want it to cancel out. 1 gallon has how many liters? You're going to help me out here. 3 point something, right? 3.79? And voila, now you can cancel out. So I'm gonna just for this one example say, hey, this went with that. That's the purpose of the first step, to get rid of the gallons, and now I'm left with liters. So that's taken care of. Then I'm gonna continue that step. You still multiply it. I know that I want to get it to hours. So 1 hour has 60 minutes. I think we all know that. We don't need that on our study sheets, I don't think. So the minutes here, way down here, will go with the minutes way up there. Okay? So we can cancel that out. So if you read what's left, you have liters on top, hours on the bottom, exactly the way you're asked to do this. You know what, it's a little tedious, but I would encourage you to multiply everything across the numerators and then multiply everything across the denominator and then divide. Some students want to do it all in one shot and they get the wrong final answer because they're rushing. Okay, so we're going to go I'm going to clear my screen. I'm going to go 42 times 3.79 times 60. Hey, did you know that even if you press clear, it's not gone? If you press arrow up, everything is still there. So if you hit clear, you got to go back down all the way and hit clear a couple times, and it would just clear your screen so you can start the new question, right, without all that other stuff there. So 42 times 3.79 times 60, that's what it is. So 9,550.8, watch, you got to make sure your units are right, liters per hour. And I'm kind of warming you up for what's coming down the road, okay? How many liters would you be able to get in 5.5 hours? So we're assuming this is some kind of pump or something, right? Or a leak, maybe it's leaking at this rate. So when it comes to, this is just converting from one to another. But if you have one of these, set up a proportion. Set up proportion. And maybe the summer made you forget what a proportion is. But it's, do you remember cross multiplying and dividing? Does that ring a bell? If not, here it is. You use this fact here. That many liters in 1 hour. Correct? And then you will ask yourself, well, if I am considering 5.5 hours, how many liters am I looking at? Does that ring a bell? This is a proportion when you put a fraction equals to another fraction. But there's one unknown. I'm going to say this. You're not converting here. Okay? You did your conversion already. Here you're kind of just extrapolating. I don't know if that rings a bell. You're saying, like, if this is true on a small scale, what is it going to be on a larger scale? So watch my trick. Every teacher has done it slightly differently. I ask my students, where is the variable at? It's on the right side. You go to the number. So you will multiply going up and divide on your way down. This is only to help you solve this. So if you just show me this part right here, 5.5 hours times 9,550.8 liters divided by 1 hour. That's how you would figure out what x would have to be. I kind of smudged it all up here. Let me just try this one more time. That's better. So I just want you to see how the units cancel out here, folks. The hours here go with the hours there. And what are you left with? Liters. That's exactly what we want. We want to know how many liters. So it's 5.5 times that divided by 1, which is irrelevant. So it's 52,529.4 liters is your final answer. So some converting, and then I ask you, hey, what about, if that's true, can you tell me a little bit more? Okay. Let's highlight the setup of proportion part, because and maybe when we do the proportion, I will highlight the equal sign, that you're basically putting two fractions against each other and you're trying to figure out how to make them equal. Okay. One more step here. 65 miles per hour to meters per second. So we start like this. 65 miles in 1 hour. You can see that, right? We're converting here. You're going from a unit to a different unit. So we're converting here. You know what? I always tackle the top one. That's just me. I'm going to try to get my miles to meters. That's going to be my goal. How am I going to achieve that? I'm going to use this fact that 1 mile, and I want it down here to cancel out the miles there, has 1,609.3 meters. Oh, that is the thing that I'm going to have to get used to. It didn't do that last year. They upgraded the system. Or I'm going to try to see if they can change the timing for that. Thank you. So miles and miles go. I have my meters here. So that's good. And then hours to seconds. 1 hour has how many seconds? 3,600, right? 60 minutes times 60 seconds. If you need that on your study sheet, just go ahead and do it, because it just speeds things up and it doesn't take up that much space. So I'm going to cancel hours and hours. So watch what I'm going to do here, just to make sure we don't get it wrong. I'm going to go 65 times 1609.3. Is that right? This is right, correct? That matches your... Yeah, okay. Good. I just wanted to make sure I don't do this whole thing and get it wrong. 104,604.5. And that is in meters. The top has meters, right? And the denominator, I'm going to go 1 times 1 times 3,600. That is just 3,600 seconds. Did you know that this is technically, that is technically okay, but I usually want it simplified. So we go divided by 3,600, and so that's what we get. That is 29.06 meters per second. Let's write down big under this, because I already want to make that point, the difference between rate and unit rate. I'm going to use that blue pen for that. This would be a rate, same as what we started with, by the way. So this is a rate. This is what we call a unit rate. They are the same in terms of their value, but this is what I mean by unit rate when it's like 29.06 meters per 1 second. Okay? I will expand on that later on. Sorry, I kind of used up a bit too much space here. How long would it take to travel 750 meters? And we look at it, it's like, oh, this is in meters per second, so that's actually very convenient. Okay, so we're going to go like this. You choose which one you want to pick out of these two, by the way. So we're going to go 29.06 meters in 1 second. So it would say, in this case, we have to put the 750 meters in the numerator. So you got to watch out. Like when we do conversions, we usually go opposite, right? Because we want to cancel out. When you do a proportion, you want to actually match the units. And so it's going to be X number of seconds. So remember my trick? You go to the side of the variable. You start with that number. So it's going to be multiplying and then dividing. You can't tell other teachers about this secret, okay? If they ask you, like, where did you hear this from? Where did you get this from? It's like, I don't know, somewhere on YouTube. I don't know. Some random teacher showed me this trick, because not everybody's fond of this. Okay. 1 second divided by 29.06 meters. So the meters cancel out here, so you're left with seconds. That's exactly what you want. Do I need you to show me that every time? No, I don't need you to have the units there. I'm okay, but I need you to see that that's what's happening. So 750 times 1. I'm not going to do that step, but it's 29.06 that we divide by. And that's 25.81. And because it's time is continuous, it's okay to have decimals as your final answer. If it's number of people, number of coins, number of items you're buying, then we usually want to round to a whole number. Okay? You might want to take a note of the, if you ever see MPH, some students, oh, it's like meters per hour. No, MPH is miles per hour, and MPG is miles per gallon. Sorry, MPG is miles per gallon. So if you ever see that, we use that a lot. Okay. I'm going to ask you to. I'm going to stop here for a bit because I think you need to wake up a little bit. I'm going to ask you to try this one down here. So do the conversion first, and then answer this part as well. So just so you know, I'm getting you ready for what's coming next. Like, I will just assume you will know that you need to convert before doing this part. Okay? So try it. I might come by and see how you're doing. So some of this I know is review. I know some of it is an intro, especially converting in the intro course in grade 10, but this isn't it. Like, we're going to do more yet. Okay? 4.5 liters per minute to ounces per second. Again, just go like this. This is, by the way, a unit rate as well, because it's per 1 minute. Every time you can say the word, you can read it out and say per 1, it's a unit rate. Okay, so start thinking of that. So what can I do first? The way I did it, it may not be the same way you did it, but I know that 1 gallon has 3.79 liters, so you can cancel the liters. I need to keep going. Oh, wait a minute. Yeah. 1 gallon has 128 ounces. Is that on your... You have that? Yeah, okay, good. I'm always updating these things, and sometimes I'm not sure. So the gallons cancel out. So when you look at the top, the liters, you've done everything you needed to do to get it to ounces. So perfect. So now let's tackle the minutes. We know that 1 minute has 60 seconds. So perfect. The minutes there, go with the minutes here. So now you're ready to solve this thing. So 4.5 times 1 times this, right? So you get 576 ounces on top, and 1 times 3.79 times 60, that is 227.4 seconds. Okay, you've turned that unit rate into a rate with different units. So the one extra step is to divide. So you get 2.53 ounces per second. We good? If you have questions, come and see me. We can always figure it out. And sometimes, mistakes happen. I'll show you how to make mistakes. I'm pretty good at it. But as long as you get back up and just keep going, you're fine. And I tricked you here a little bit. So I made you convert, and then it says how many liters in 35 minutes? Ounces, seconds. This one doesn't really work here. So you actually want to use this one. 4.5 liters. I didn't mean to trick you, but I want you to read. Okay? So in 35 minutes, it's X number of liters. 35 times 4.5 divided by 1, and that is 157.5 liters. If this had been a dollar amount, you would want to put a 0 next to your 5. Actually, it doesn't hurt. Dollar amounts have to have 2 decimals, but there it is. You could have used this, found out, how many ounces, and then turn it all up. Like, it would have been a lot more work. It's all connected though, so there we go. Okay, that's that. So I will say, I'm going to skip the you try for now. And I will go down to on page 5, I will continue with this part right here. Because to be honest, the top part of page 5, we've kind of done that just now. So I'm going to go just page 5. Determine the better rate, or I can call it the best buy as well. That's going to be part of it. So I'm going to highlight that. If you ever want to know the better rate, like which one is better, make sure you use unit rates to make that decision. Don't just leave it as is. Don't just make a guess, right? Units need to be the same. Okay, so that's very important. Units need to be the same. You convert as needed, always. Then determine the unit rate, and you usually find it by going numerator divided by denominator, and then state the better rate. And usually I'm going to ask you by how much is it better. Is it $1 per kilogram better? What is it? So it's always going to be a rate. So these are usually the 3 things that are involved there. So if you ever go to the store and it says $2.99 for 3 pounds, I don't know, potatoes, whatever you want to think of, the way to get it to a unit rate is simply to go 2.99 divided by 3. Like you go numerator divided by denominator, and you get, rounded, $1 per pound. Okay, so this is the unit rate here. This is what we would be after. So just divide. We've been doing that already. Okay. Another important reminder when it comes to this unit: cost divided by quantity is the way to go. Okay. So another. If you ever have dollars, dollars should go on top. Listen carefully, dollars should go on top. And underneath you have quantity, like how many you're buying or how much. So this box is saying whenever there's dollars, always put it on top and then divide it by the bottom, not the other way around. Another important concept is fuel economy. Okay, the amount of fuel used per distance traveled. It is usually stated as liters per 100 kilometers. So I need you to be comfortable with fuel economy as well. And I will give you a formula because it's easier. Like, I don't want you to spend too much time on figuring this out. So I'll just say this, and I ask you to add this to your notes as well as study sheet. Fuel economy is simply liters used divided by distance traveled, and then you just multiply it by 100. And your answer is always going to be something liters per 100 kilometers. So that's important, that the answer to this formula, whenever we use it, is going to be, this is how many liters per 100 kilometers this car uses. Make sure you write that down. If you're a highlighting person, you go for it. Add it to your study sheet. Just do it. Fuel economy is very common. Shows up all the time. Okay. All right, let's keep going. Page 6. I want you to become critical thinkers. You read your questions, you figure out what's happening here. I don't want you to just blindly follow my steps. Okay? Which is the best buy? Right? There's the best buy, best purchase. And by how much? So ultimately, I want you to answer those 2 things. Is it a turkey at Safeway for 12.8 kilograms at $42.89? Or is it buying a turkey at Superstore for $1.49 a pound? Like, which one is better? It could look different for everyone, but I'm going to start with Safeway here. I like to compare them side by side. And so I'm going to go Superstore over here. It's on page 6. And I'm going to make note of something. Yeah, go ahead. I'm going to make note of something. $1.49 a pound. What kind of rate is it? It's $1.49 per 1 pound, right? For 1 pound. This is already a unit rate. So I'm going to circle that and say this is already a unit rate. So it would be smart in this case to try to get the other, like Safeways, also to dollars per pound, and then you're done. Then you don't have to do a bunch of converting for no reason. So I'm just going to say Superstore is already done. We don't need to do any work there. I'm just going to say $1.49 per pound. That's going to guide my work. So I'm going to start with Safeway. It is $42.89 for 12.8 kilograms. Remember, dollar's always on top. Right? This is the cost divided by the quantity. Right? That's the pattern. And there's something wrong with it. This one is dollars kilograms. So that's the first problem, that it's a different unit. The second problem is that this is not a unit rate. So there's two things here. So I'm going to convert. I'm going to leave the dollars. I don't need to worry about it. I just need to worry about the kilograms. 1 kilogram has 2.2 pounds. Right? So cancel, cancel. I'm basically, that's all I needed to do there. So I'm going to go 42.89. 42.89 times 1. And I'm going to multiply the denominator here as well. And the reason I do have my key, but I do think there's something about me working through it, not just giving you the answers and just going with it. So that's why I use my calculator with you. Okay. So now we know what the price is in pounds, like per or for the pounds you've purchased. I'm just going to divide these now. Okay. I'm going to go 42.89 divided by 28.16, and that's 1.52 in this case. So it's $1.52 per pound. Now we're talking. Now we have, so this is a rate. This is the unit rate. This is also a unit rate. Okay, so this is good. So now we can say, which one is better? Oh, Safeway because it's bigger number, Mr. Jerkson. No. You want to save money, remember? So this is the better buy. So Superstore is better by how much? You do a little math on the side here. 3 cents, that's it. So by 3 cents, but that's not right. 3 cents per pound. Yeah, you're saving 3 cents for every pound you purchase. Okay? So this is the final answer there. So I wish I could give you a cookie cutter approach. It's always going to work. You have to be smart about it. And just make sure that these unit rates are the same in the same units. Everything is the same, other than, of course, the amount in this case. All right. Let's do one with speed. Which is faster and by how much? Traveling at 14.2 meters per second or 50 kilometers per hour. What would you like to do? You have to make a choice. I'm going to turn, what does my key say here? I think I'm converting my meters per second to kilometers per hour. No, I turn my kilometers per hour to meters per second in my key, but you decide what you want to do, okay? Maybe I'll turn this to meters per second, okay? Convert to meters per second. So 50 kilometers in 1 hour. What am I going to use here? I'm going to say, well, 1 kilometer has 1,000 meters. If you don't know this, add it to your study sheet. Okay, kilometers, go. And I know that 1 hour has 3,600 seconds. So that hour goes with that hour. And you multiply everything out. You get 50,000 meters if you multiply out the numerator, and the denominator is 3,600 seconds. It's a rate, but it's not the unit rate, so we'll divide one more time. So this divided by that gives you 13.89 meters per second. So that would be for sure 1 mark already there. So which one is faster? I know I have one where like it's a pig versus some other animal running a race, right? So it's the same idea. You just need to figure out, have them both in the same unit. And there you go. So we're going to say 14.2 meters per second is faster by, you just need to do a little bit of math on the side here. Anywhere on the side. That turns out to be 0.31 meters per second. So I just did this on the side, right? So it's faster by 0.31 meters per second. So let's keep going here. I'm bombarding you with a lot, and it's only Friday. Let's go to page 7. I have to emphasize that you may be able to answer the same question differently using your own method, right? Like you could have answered the previous question by converting both of them to kilometers per hour. However, because it's a nightmare to mark it that way, I will often tell you on the quiz or test, answer in meters per second, for example, or answer in kilometers per hour. So you know it's kind of like a prompt. Okay, convert everything to kilometers per hour there too, for me to answer it. Okay. Here we go. Which car has a better fuel economy? I'm going to highlight fuel economy because it should ring a bell, right? You should be like, oh yeah, I have that on my study sheet. Car A uses 32 liters to travel 500 kilometers. This is on page 7. Car B uses 11.5 gallons to travel 300 miles. Okay, so I'm going to say that we need kilometers and liters to answer this. Oh, you can't see that, right? I'm going to figure this out. What can I do to fix this thing? I try to... If anybody's very tech savvy in here, this is Windows 11. I'm still figuring out how to use this. We need kilometers and liters to answer this. Okay? So I'm going to do a little bit of math on the side here. I'm going to convert my gallons to liters and my miles to kilometers. That's what I'm going to do here. So there's some converting here. This is what we started off with. Not too bad, right? So 1 gallon has 3.79 liters. Cancel out the gallons. That is the equivalent, if you multiply, that's 43.585. I'm not going to round just yet. Okay. And I'm going to take my miles and turn it into kilometers. One mile has 1.6093 kilometers. And I'm probably going to run out of room here, but I'm going to try it anyway. So 300 times that gives me 482.79 kilometers. Okay, so I've done everything I needed to do with car B to have liters and kilometers. Car A already has it that way. So I'm going to say this. Car A, the fuel economy, according to my formula, is liters, right? 32 liters divided by 500 kilometers times 100, and I'm going to get an answer there. Car B, the fuel economy is 43.585 liters. I have that from here. Divided by 482.79 kilometers times 100, and we're going to get an answer there. So 32 divided by 500, and I multiply it by 100, that's 6.4 liters. And you're like, that's not a unit rate, Mr. Dirksen. You are correct. But when it comes to fuel economy, that's like the standard in Canada to state your fuel economy. Otherwise, it'd be a very small number. Then I go over to my next one, 43.585 divided by 482.79. So look at that. I need you, as we're going along, do you see that E negative 5? That's like scientific notation. That's like saying times 10 to the power of negative 5. It's a very small number. But I have to multiply that by 100. Oh, I made a mistake. I forgot to put the decimal down. So I'm going to copy paste that line and just go 482.79. There you go. That's what I'm supposed to get. Times 100. So this is 9.03. I rounded to 2 decimals at that point per 100 kilometers. So which car has the better fuel economy? A, right? Because it uses less per 100 kilometers. So car A has the better fuel economy by 2.63 liters per 100 kilometers. So that's kind of like the one exception to the rule where we don't use unit rates. If you used unit rates, I would be okay. If you're like, no, Mr. Erickson, I don't like your formula, I'm just going to turn it into a unit rate, you are technically correct. Right? You would, though, have to come up with the same answer, right? Same conclusion. All right. I'm going to stop there. If I go to page 13 here real quick, I'm just going to check. I feel like I had... No. I asked you to do 13. Still do it if you haven't. But what I'm going to ask you to do instead is if you go back in time here, starting on page 4, So basically pages 4 to 7. And I know it seems like a lot because like 4 to 7, but there's a lot of space to do your work. 4 to 7, everything that we haven't done, anything we haven't done between the pages 4 to 7, I would like you to try. Okay? And I will post the answer key to that. And let me tell you this, especially now, you need to once start strong. You need to like spend some time figuring this out. So you know what questions to ask even. If you're not sure what to do, this is what's going to help you actually ask me, like, what this right here, I don't know how to start here. But just give it a try, okay? And again, if you feel like, you know what, I got this part, maybe you do half of page 4 and continue and do some other questions, that would be okay as well. But just remember to work hard.